Hi, in this video we're going to use our thermochemistry that we learned in the previous video to do some practice problems. So our first question says, how many joules of heat are needed to change 50.0 grams of ice at -15 degrees to 120 degrees? So let me draw out real quick. Our situation here is from solid, this is 100 degrees, this is 0 degrees. From -15 degrees, this is solid, liquid, gas. -15 degrees over here, and it changes all the way to 120 degrees over here. So this is our gap. Alright, and from using this change, we're going to go through every single formula that we have. So we're going to use Q1. Q1 is equal to mCp delta T, which is this one. Q2 is equal to this one, which is mH fuss. Q3, which is this line, is mCp delta T. Q4, which is this line, Q4 is equal to mH vape. Q5 is our final one in the gas form, which is mCp delta T. So we're going to have to find all 5 of these and add them together in order to get our answer. Alright, let's do this little by little, alright? So all of the M will be 50 grams because our grams does not change at all. It's only the other 3 that changes. So Q1 will be equal to mass, 50 degrees, times Cp. So Cp for ice is 2.05. And this is given information. Times our Cp. Cp is temperature change. And since we're only looking at this little range over here, we're only going to use 0. Final is 0. 0 minus -15. Because it stops at 0 degrees, because that's where the solid part ends. So we're going to use this formula for Q1. Q2 is going to be 50 times H fuss, which is 334. Q3 is 50 times Cp for liquid form. Cp for liquid form is 4.18. And times that by, let's see, this time we reached 0 degrees and we're capping out at 100 degrees because that's all the liquid form takes. So we're going to use T final, which is 100 degrees, minus T beginning of liquid, which is 0 degrees. Now Q4 will be 50 times H vaporization, which it will be 2,260. Finally, Q5, which will be 50 times 2.02 gas form times, let's see, the temperature that we're hitting the max at is 120. So we're going to use 120, which is the final temperature, subtracted by the temperature that we are beginning with, which is 100, in only considering the gas state. Because remember, these formulas are only in the state that they're in. So the T final and T initial need to be adjusted. So this will be 120 minus 100. Now we're going to solve for every single one of these Q's. First one, you should get 50 times 2.05 times 15 gives us 1537.5. 50 times 334 gives us 16700. 50 times 4.18 times 100 gives us 20900. 50 times 2260 gives us 113000. 50 times 2.02 times 20 gives us 2020. Now our job is to add all 5 of these numbers together. And it will give you a final answer of 15415.7.5. And if we were to round it to the correct number of significant figures, which is 3, we're going to round it to 154,000J. Now, are we increasing temperature or decreasing temperature? We're increasing temperature. That means the amount of heat should be positive. Now, how many joules of heat is needed? If we're reversing it, like if the temperature is decreasing, then make sure you remember to add a negative sign in front of joules. But this one, we're increasing temperature, so our final answer would simply be 154,000 joules of heat. Heat energy. How many grams of ice will be melted by obtaining as 18.0 grams of steam is condensed at 100 and collected to 0 degrees. All right, so let's draw the situation over here again. And this time we have solid, liquid, gas. We have 100 degrees, which is over here, this line, collected to 0 degrees. All right, so ice melting, this line is the melting line. So how much ice will be melted by using the same energy from here? So these two has to be equal to each other. So our formula will be Q equals mH fuss, which is the formula for this line, has to be equal to these two multiplied together, which will be not multiplied together, added together, because it's a heat added together for both of these. So it'll be Q equals mCp delta T, this line, plus Q equals mH vape, so this line. And now this question, if you understand it properly, is just going to be what is this line has to equal to the two of these lines combined. So 18 grams times so the number we're looking for here is m, the number of grams of ice. So we're going to use x times heat of fusion, which is 334. And now remember, since it's decreasing temperature, right? 100 to 0 degrees. Make sure you add a negative sign for your joules. Equals 18, this time we're talking about 18 grams of heat. 18 times 4.18 times temperature change, which is 100. Negative 100. Plus mass times H of vaporization is 2260. So let's see what this number gives us. 18 times 4.18 times negative 100 equals plus 18 times 2260. Now, a thing to remember is that this has to be a negative number as well. Why? Because, again, we're decreasing temperature. So 18 times 2260, that should give us an answer of negative 48204 joules on this side and negative 334x on this side. So this way we can simply solve for x by dividing both sides, and that should give us an answer of 144.32, which rounds to 144. And this is the number you're going to get after condensing 18.0 grams of heat. Thank you for watching.